Hello students, today we'll discuss some past paper questions on AP. So let me introduce the first question here. So this is the first question. It is given that 2k plus 1 k square and 11 are three consecutive terms. What do you mean by consecutive terms? Three terms in order of an AP. Find the possible value of k. So that means I can take the first term as 2k plus 1, second term as k square, and third term as 11. And if a1, a2 and a3, say a1, a2 and a3 are, say, first three terms of an AP, then by the definition of AP, the difference between the consecutive terms remains the same. That means difference between A2 and A1, A2 minus A1 is same as the difference between A3 and A2. Now here, the second term is k square minus the first term is 2k plus 1, that is equal to third term is 11 minus the second term is k square. So k square minus 2k minus 1 is equal to 11 minus k square. So shuffle the terms. K square, take minus k square on the other side. K square plus k square is 2k square minus 2k minus 1, take 11 on the other side. Minus 1 minus 11, that is minus 12. So here I can take 2 common. It will be k square minus k minus 6 equal to 0, which gives k square minus k minus 6 equal to 0. So you are getting a quadratic equation here, and as you can see, this equation is easily factorizable. Factors of 6. Now the sign of the constant is negative. That means factors of 6 such that difference is equal to 1. The coefficient of k, that is 3 and 2. And since I want negative 1 here, negative 3 and positive 2. That means two factors of this quadratic are k minus 3 and k plus 2 is equal to 0, which gives k minus 3 equal to 0 or k plus 2 equal to 0. And hence two possible values of k are 3, k is equal to 3, or k is equal to negative 2. So two possible values of k are 3 or -2. Let us see second problem here, past paper type. So this is the second question here. And AP has first term k square. That means it is given that A is equal to k square. The common difference is k. That means D is equal to k. And the fifth term T5 is equal to 21. Now, it is given that k is greater than 0, k is positive. Find the value of k. So, here I am going to use the nth term formula. Tn is equal to a plus n minus 1 into d. So, T5 is a, that is k square. Now for fifth term, n is 5. So 5 minus 1 is 4 into d, that is k. And this is 21 given to you. So 21 is equal to k square plus 4k. So this I can write it in a standard quadratic form as k square plus 4k minus 21 equal to 0. Now I am getting a quadratic here. What are the factors of this quadratic? Now the constant is 21. Obviously your k square coefficient is 1. So I am just considering the constant, and the sign of the constant is minus. So difference of factors of 21, difference should be 4. So what are such two factors? Yes, 7 and 3. I want plus 4, that is plus 7 minus 3. And hence the two factors of this quadratic are k plus 7 and k minus 3 equal to 0. Now equating each factor to 0, I get either k is negative 7 or k is 3. Now be careful, it is given that k is greater than 0, k is positive. That means out of these two values, only one value is acceptable, that is k is equal to 3. Since k is greater than 0, so we will not accept minus 7 as one value of k. So which these steps are okay with you? I will give you two sums for your own practice. So just take these two sums for homework. Try them yourself. These are very similar problems. If any doubts are there, make them clear in the next class. So see you in the next class, students. Enjoy the day ahead.